So welcome everyone to the pro-micron spike webinar. And as you know the rules for this session, I would ask you to turn off your microphone, listen carefully, but you always have the chance to interrupt me if you can't hear me correctly, or if you have a direct question. You can mention it live, or you can even type it in the chat, and my colleagues will tell me someone has written something in the chat, and I can answer the questions afterwards. As you know, the main topic of the webinar session, which we have started many weeks ago, is how Spike can help you to save costs. And we nearly reached the end of the session. Today we have the user cases and FAQs. With this event, we want to summarize a little bit, and we want to give some more examples on specific topics which we have been asked from the attendees from these webinars. And we have prepared 3 topics which I will explain shortly. Again, maybe someone will leave more early this time. I want to remember or remind you for the online event, which will be done next week from 1st to 3rd of July. There we will have the DMAP. The DMAP is the marketplace for digital machining, and this is an online event from 12 companies and institutes running an online exhibition. And via www.digitalmachining.de you will be able to sign up for webinars, for specific speeches, or even for a manager or a director's exchange. And here you will see how companies you see here: Starma, Haas, pro-micron, Regofix, Cerecitit, Ölheld, or institutes will discuss together or present together their solutions for digital machining. You are very welcome to join these events. So let's start with today's topic and with today's agenda. We have been asked from 3 customers to prepare a trial and to prepare more information, a user case, and we decided to pick these 3. We want to start with process parameter optimization. Oh, I need to add my battery charger, sorry. Okay, now it works better. And so the first topic is process parameter optimization. The second one is tool lifetime analysis, and the third one is threading, because we didn't discuss threading at all during the last meetings, and it's a very very general or very often used monitoring application or for mass production, so this is also very important. How is the process? First, I will explain you some theoretical basics and the approach, for example, of optimization, and later on I want to discuss a practical case. You remember this slide, and you remember the benefit of these webinars, that we are doing applications live on our machine with our application engineer Dirk Mössing. For this session today, unfortunately, it's not possible to run tests on the machine, since we need to prepare the applications and the setup for DMAP, which will take place next week. But last week we were able to do it in German, and running trials on the machine. And the threading one, for example, I recorded also my screen, and I would like to show you here the impressions and the results which we have recorded. So let's start with process parameter optimization and with the theoretical basics. And to summarize here, I would like to start with the approach, how to do optimization. What are my key options? And I want to show you 4 examples. I know there are many more, and you as an expert, especially the process experts and process experts, know how to optimize the best. But here I want to just show you again how Spike can support you in process parameter optimization. The first point is that the effect is that we want to reduce vibrations, and here we have 2 tools. We can adjust the RPM or the depth of cut. A second approach for process parameter optimization is to increase, the goal is to increase productivity. How can we do that? To adjust the feed and the RPM. The second one is in order to have a longer tool lifetime, we want to reduce the force load. So here again, we need to adjust our parameters. Another trial is for increasing the tool lifetime is to adjust the parameters and then doing long time analysis, process evaluation. And these 4 I would like to explain you more in detail. So the first one you remember from webinar session 3 is that if we look at the theoretical understanding, we have different tools in different AP or different RPM can reach a stable or even an unstable situation. And these dynamic effects we want also to analyze with Spike. That's why we have run a test trial with different RPM and different volume of cuts. And we have seen that we have different maximum banding values, and we have a different size of amplitude. If we look in the graph, and we are looking at the filter 1 in order to detect dynamic effects, we can see that the force level is nearly the same. All have a high amplitude, but in processes where the amplitude is a little bit higher, we also have seen vibrations in the process. So in the raw data signal from banding moment, it is not such easy to differentiate. It is much more visible, these vibration effects, if you look at the Spike polar. And here, by adjusting the parameters step by step, Spike helps you to give you professional feedback on process condition, and therefore Spike helps you to find the optimum process parameters much faster. A second approach for process optimization is mainly driven by the effect that you want to increase productivity, is that you increase the feed rate. I think this is clear to everyone, and it's clear to everyone that if you increase the feed rate, the force level will also go higher, will increase. We had the same effect here. We are now looking at torsion with 100 points. We have the first process is the blue one, then the orange one with 1 meter per minute feed rate, and the green one is even double feed rate again. Now we just want to see which effect the increase of or the doubling of the spindle speed, which effects do we get in the force value. And here we can see by doubling the speed from 6,000 RPM to 12,000 RPM, we have reduced the torsion by 40%. So we reduced the force load. And we are nearly on the same level like with a feed rate of 0.8 meter per minute. Sure, the process time can be reduced by this, and we can even identify more potential for further optimizations. But we also need to know, this is theory, we need to analyze if this process condition is also good for tool lifetime. But we also need to compare if tool lifetime and process time reduction, which of these two effects is more important in my operation. The second trial is where we are looking at a milling notch with a 6 millimeter end mill cutter, and we have done a long time test. That was on a mass production automotive or in automotive industry, and the challenge of the customer was for us to say, when do you change your tool? He said after 4,000 parts, and he wants to increase the tool lifetime. So first we continued the operations with the same tool above 4,000 parts, and the first feedback we get was we can still use the tool even after 5,000 parts, but afterwards the tool was wearing out too fast, and here we reached the end of tool lifetime. Then we were looking at the absolute forces in the bending moment, for example, and the machinist also said, let's minimize the peak in the forces so we can get so we don't have too much force load on the tool. We did this. We changed the depth in that direction, and we reduced the feed rate at the point of maximum tool engagement. Because of this, we were able to reduce the force load, but the bigger effect, and where we need to focus on, is that by doing now a long time test, we have seen that the tool life slope was much smaller than we had it in the beginning. And because of this process optimization, now we're even able to run 6,000 parts. After this trial, the customer said, I need to test that more and more. I need this tool holder now. And he told us that now, or after using Spike for some time, he's now changing the tool after 8,000 parts. So, and which calculation for amortization did he use in front of his management? It's an automotive customer, as I said. They are producing millions of parts, and this part has several tools. And the tool 3H is taking 9% of the tool cost in this operation. And now he increased the tool lifetime by 50%. So he reduced his cost per piece, cost per part. And if we do an amortization calculation, he was able to save 7,874 euros just on this tool by these optimization steps which we have done. So adjusting the parameters, finding the right parameters, and then doing long time verification is my message to you, how to use Spike and how to even argument it in front of your management for a cost amortization. Here I would like to show you another example. This is now from the aerospace industry. We know aerospace processes, if they have been defined once, they are qualified and no one will change it. Here, there was a huge discussion with the customer or on customer side if they really have the optimum process parameters. And we did this trial with the tool manufacturer and the end customer together. In order to find the cost-saving potential and process optimization. The customer said he's changing his tool after 6 parts every time for safety. So we have run a test with the tool until the end of tool lifetime. And as we can see here, and by looking at the surface quality, we were able to run 8 parts with the same tool. So again, here we had the first information or first benefit of Spike by seeing, look, how much tool load do we have, and we know the tool can handle more. But now the motivation was, can we reduce the tool load? And that's why the customer changed the AE from 0.3 to 0.25. Sure, everyone would say, simple. I know that I can have a longer tool lifetime if I have a different AE, but for the end customer, he didn't have any information and any feedback and any data. Spike was able to give it to him so he could go to the management and discuss it more in detail. And we have done this test within 7 hours. And within these 7 hours, we were able to increase the tool lifetime by 83% and reduce the annual cost by 45%. Sure, you could say, but now you lost productivity. But then we also told that to the customer, and we asked him, is that a problem? He said, no, this is not a problem, because the tool change time was also reduced, and therefore we had the same productivity as before. And the key effect was the 45% tool cost saving. And this was the effect the management was using to talk to the production team and say, we need to adjust our qualified process parameters because we are wasting so much money on tool costs. And we were really impressed. It worked, and they changed the machining, the production process. It was really incredible, and we were just able to do this within 7 hours. And I cannot tell you the exact numbers, but within nearly half of that time, we already amortized the investment of 30,000 euros by using Spike. Now I would like to show you the vibration effect again. And in the webinar which we have done last week, we were able to run this operation live on our machine. We were using a tool from Ceretit and a clamping system from Regofix, the PG25. Perfect condition with our Spike system. And we were using first the process parameters which we got from the tool manufacturer. And the trial plan was a milling operation of 5 cuts with increasing change of RPM by 5%. So the first pass with 3,195 RPM, we achieved a maximum bending moment of 26.4 Newton meter. We had an 8.3 Newton meter amplitude. And here I want to show you again the noise signal. We are looking here at the filter 1 raw data. And in this operation, it was a roughing operation. You can see nicely the noise force difference, which is very important to look at it every time. And it took a picture of the surface quality. Also in the Spike Polar, we can see the 4 flutes, and we see that the line is very thin, so we have a good condition. Now we increase the spindle speed, and we receive new information. We have a higher bending moment and nearly the same amplitude. In Spike Polar, there is not a big change. Then layer number 3, process number 3. Amplitude is getting bigger. The bending moment is nearly the same, and we still don't see a big difference in it. So let's increase the spindle speed more and more. Yeah? And now we have seen this. We see 3,675, and we got the data. The surface quality is also still good. But at the end, by increasing the spindle speed to 3,834, we have seen in the amplitude and very nicely, which can be monitored very nicely, in the spike polar that we have vibration in this case. Amplitude is bigger and even the bending moment is getting bigger. We also see in the surface quality that it's not good. Sure, you could say for this process optimization or finding these parameters, we don't need spike because I see bad quality and before we had good quality. But what we can analyze now more in detail is that high amplitude means high vibration in the process, which we had in process number 5. But by looking at the full amplitude and the force level, we see that we have the best condition and the smallest bending moment in operation number 4 with this spindle speed. So why not keep going with this spindle speed? Now I would like to go into the next topic with the tool life analysis. First, again with theoretical basis, with the approach of tool lifetime analysis, and then I want to show you some results of practical cases. What's our approach for tool lifetime? And everyone, especially tool manufacturers, need to do tool lifetime tests. The main goal, why to use spike for this, is definitely to reduce the effort and to save time. How can we do that? Record the data with a trigger function and not with with a manual start and stop. Because of spike, we reduce the effort to do wear and quality pictures periodically. Yeah? So we only need to do the pictures every 100 times and not every 10th time. Yeah? A very good reduction of effort. And we have the tool analysis function. We can do detailed tool analysis in the tool analyzer software for dynamic changes, to analyze dynamic effects and so on. I would like to show you 3 examples, tool lifetime trigger and without the trigger function, a coating comparison, and an example for a ball end mill. Maybe you know these examples from my further presentations before or from my colleagues, but it's always good to hear that again. This is an overview of the product portfolio which we have presented to you. And here mostly we are talking now to process experts, and they use the diagnostic set which we call Spike Expert Line. This information can be used for visualization with Spike Assist and Spike Easy Inline. That's why and how I would like to explain later. First of all, this is a very standard toolware analysis example. The customer said, I have a material block or a block of a specific material, and I have a tool and I'm running stable cuts. He said he is doing now pictures every time, as he did here, at the end of 1, 2, 3, 4, 5, 6, 7, 8, 9. 15 sessions or 14, 15 sessions, and he was taking a picture here. It needs more time, but it's very important to have the correlation between tool wear, force data, and surface quality. You always need to do that, but Spike helps you now to run the test much faster. Here, we did not do the measurement automatically. We did not use the trigger function. Still, we achieve the same results, but as you have seen before, it is much more convenient to start and stop the measurement with a trigger, and you are able to record several more data than only these single cuts. Now we have done a long time analysis test, and this is a coating manufacturer and or a tool manufacturer, and he was comparing different coatings. The customer told us he needs 1 week to receive the results which we have generated with Spike within 3 hours. Yeah. How does that work? He has 4 tools, different colors here, and he said, I'm doing a picture in the beginning of the tool, and I have defined that I need 100 operations, and after 100 operations in order to produce a little bit of tool wear, then I do a tool wear picture. And you can see here the purple one has the biggest wear, the green one has here this corner in it, and it's getting really difficult between the 2 blue ones. This is the spike data, especially in milling. We are looking at bending moment, how it looks like in the beginning. Yeah? And this is the force data after 100 operations. Here we already see a force change, and we see that the spike polar still has the same graph, but a wider range. If we use now the tool lifetime trigger, then we can compare tool lifetime and that of different tools or different conditions very easily, and we don't always need or only need the pictures. And with this result, you can achieve the conclusion very quickly. And blue and light blue are performing nearly the same. The purple one, which he expected to be the best, was definitely not in the right range. And the force level straight from the beginning was too high, and also the increase was also not good. There might be a discussion between experts that why is some say the green is the best, but some say the blue ones are the best, since the slope is for the green one is definitely the best. Do you remember the picture of the green one before? There we had already a scrape in the helix, in the cutting edge, and this was causing the higher force straight from the beginning. So here the customer already had a very easy feedback by having the picture and having the force value that the blue ones had the best performance. My last example is from die and mold with a ball end mill, as I told you before. And here again we did a long time test. The special issue is that the thickness of removing material is very small, and it's a light finishing operation. And the customer wants to know when to change a tool because when he is producing bad quality. He wanted to reduce the effort of quality check afterwards. That's why we are looking now at the bending moment development. And as you can see here in the beginning, we have still a new tool. Then the tool is wearing out faster and faster. And at the end, there was even a tool cutting edge breakage. We were looking at the spike polar data as well, since it's the same like the bending moment. And we have seen that at the end, so from 400 to 500 meters, the tool was, or the bending moment was negative, the slope, the relative change, compared to the normal one. And we thought, what is it? And what's the analysis behind that? And by looking at the surface quality, we have seen that the RA value was getting better and better. That was even strange. But the tool was wearing out faster. The problem in this case was, and this is something for die and mold, the customer told us, which is the most important issue. the dimension of the workpiece was out of tolerance. He said exactly this process, this step from 0.02 millimeter to this 0.06 millimeter. This is the problem. This is out of tolerance. So here, by looking at the bending moment data, we were able to see that if we have a negative change in bending moment, there we have a quality related issue. And this is where I want to remember you to the spike KPIs which you have heard before. We have spike polar and we have the spike KPIs which can be process specific. And here we are using now the bending moment, for example. Doesn't matter which scale we have here. It's getting red because of negative trend, and this is the signal to change the tool or to have a look now at the surface quality. This is a typical tool lifetime test which we have prepared with the Hachenbach Präzisionswerkzeuge tool manufacturer. It's a tool manufacturer Hachenbach, and we did this test with Spike, and he compared his tool against the same type of tool from his competitor. And as you can see here in the color, and you see the results, in the beginning they have the same values, but at the end, or by looking at the number of produced parts, you definitely see the difference. Now, what kind of information, we have now the tool lifetime information. How can a tool manufacturer use this as information for his end customer? As we see here, if we take 40 Newton meters as 100% from the beginning, we see that by reaching 50 Newton meters, we reach a quarter or 25% plus, and we reach the 50%, and by 50% more, we reach the situation before the tool breaks. If we look at the Hachenbach tool, we see the same effect, but the tool load is totally different. Here, the tool reaches its end of tool lifetime after plus 100%, so even later. Why am I talking about the relative change and the percentage? Because of one reason. Pro-micron will release soon the Spike Assist solution, which is an assistant system, for example, when to change the tool, for the machinist. He will see the bending moment and the torque live in percentage on a tablet, and he can set alerts in percentage when he wants to receive a notification on his mobile phone. That means put in the 50, the 25 or the 50% with this information from the machine, from the tool manufacturer, or use the same kind of information from the Hachenbach tool, and you can support now your machinist for tool lifetime for a tool change by monitoring the process load with the Spike app and the Spike Assist solution. This is a quick view again into the Spike app, mobile warning function for the machinist. If you can download the app for free. If you are running the Spike Assist system on your machine, or even on several machines, you can scan several systems and even several tool holders on that machine. And here you will see the different alerts which we have reached, and you can even click on it and open the last minute of that process, and you can see why you reached that limit, why this alert has been happening. So now I would like to go into the third step in threading, and again I would like to show you theoretical basics and then the practical case. Here I can show you the video which we have recorded from the first operation. In tapping, many customers also still use the spindle motor system because they say torque and feed force is the most important one. Sure, these are very important. Feed force you can see here also in the axial force in the blue graph, and you see the torque. But remember, spike also shows you the bending moment. And by just looking at 3 of 25 tap holes, we can see the same process development in red and blue, but we can also see differences in the tapping operation itself by looking at bending moment. Here we have another trial, also threading with an M6 thread, and you see here the torsion and the bending moment signal. 2 of 9 holes have a special situation, and you can see here this peak, and you can see here this peak at the end of the operation. Only 2 of 9 have this. The customer asked us in the trial directly, what is this? And we said, we don't know, let's check the quality. And what happened? We had a chip clamping, and so a bad surface quality of the thread in number 5 and number 2, 4, 6, 8, yeah, in the last one, or nearly last one. So these peaks give you a signal or the information that you have, for example, chip clamping. So a very easy measurement signal of the bending moment to monitor quality related issues. But as I also had a customer, he said, I have a huge number of a high volume production with tapping, and my biggest problem is suddenly the tap is breaking. And this case was this customer asked us to show something about tapping and the potential of spike, how to solve the problem. And we told him that we should not only look at the tapping operation, we always need to check the pre-drilling operation before as well, because maybe the pre-process has a bad condition or is not perfect. So the after process, the tapping will cause for tool breakage and then machine downtime. And remember, we can detect the deflection of a drill with bending moment, and you remember this picture, and maybe hole number 16, which is out of tolerance, we can only see it in the bending moment, would cause a tapping breakage afterwards. So that's why we have set up a trial with 10 holes, pre-drilled holes, and then we put in some of them are good and some of them are bad, and then we put in the tapping operations. And we were lucky in the last video which we have done, the tap did not break, but the process before which we had done, we exactly caused that problem. The tap broke because of a bad drill tolerance, a pre-drill tolerance. So we are comparing threads with M5 threads with several pre-drillings which have an error at standard parameters. We were using again a Serrated tool. We are running 10 pre-drill holes, but the pre-drill holes, some of them are mistaken. The first one is with a diameter, a pre-drill of 4.1 millimeter. Here the drill was too big. Then we used 4.3. The drill was too small. And later on, with the 4.3, millimeter tool, the drill was in a perfect condition. So we just used 3 different tools to produce different sizes of holes. After that, we continued with 4.2 millimeter drill, so with the right drill, but centered, without centering, with the offset problem and with the tilting problem. Let's have a look at the first trial. In the first trial, we wanted to see, do we see any effect in the data and in the quality if we have too big or too small diameters. This is the screen you remember. We have the Tool Control Center software, and we have here a picture inside the machine, with a video inside the machine. So let's see what the forces tell us in this operation. Again, we see the axial force, we see torque and bending moment, and we see here the spike polar life. That was the operation with the with the first tool. Here you see the function again of the new Tool Control Center software to switch between tool holders very quickly. We need to set up the scale. We could also use the auto scale function. We just press Terra or null once, and we can record the data. Now we have a drilling operation with another tool. And now we're using the 4.2 millimeter tool, which is the right one for the threading operation. We switch again to a new tool holder. Dirk was always using the right scale here. Normally you can just use the auto scale function via this button. Oh. Now they started. We did one hole, and after that, as you remember, we finished the last 8 operations as well with the 4.2 millimeter, but now we had different mistakes in it. And have a look at spike polar and the bending moment. It's just changing now, and here you can see really nicely the effects on spike polar. Was still without centering. Very good. So now I would like to show you the comparison of these 3 drilling holes with the different diameters. First, we are looking at axial force, so 4.1, 4.3, and 4.2 millimeter, the torsion signal, and the bending moment signal. Yeah. the different effects of different diameters cannot be seen in all of these measurement signals. Yeah? So they are very close to each other and very nearly the same. So we just wanted to show you that these little effects cannot really been seen. The bad drilling diameters can only be, but the drilling parameters can only be detected in the following threading process. That's why we were now setting these threading holes in it. We did not do the thread in one cut. We did it in in 3 single steps. Unfortunately, he was not using the right scale here, but these have been the 3 cuts, and you see in the a little bit the difference already. Now we are running the 4.2 millimeter. Here again in the tool analyzer, now we see the comparison of the 3-step processes in threading. We are looking at the axial force, we are looking at the torsion, and we are comparing the bending moment graphs. Here you can see now that in the torque signal you can see the difference in forces, or the difference of these 3 diameters can be seen the best. Yeah. So in the threading operation, effects of the pre-drill can be seen. Now we finished with a second trial. We were running the threading operation for in the pre-drill holes, which had different mistakes. And as you remember from that, is the mistakes are the same as we had in the webinars before. First we had with centering, then without centering, then with a big offset, and then with a tilting error. Yeah. The different quality to be seen in bending moment signal, not in the red signal, torsion, or even the feed force. Let's see how the threading operation looks like with these drilling mistakes. As you can see here, this is the live data now, and it's pretty hard to directly differentiate between good and bad. That's why the analysis is such important to be done in order to set alerts later on for monitoring. Yeah? Now the more the worse pre-drill holes are coming, and here you can see really nicely the effect in the spike polar, and the force level is increasing in the threading operation because the pre-drill is not good. Now Dirk was even going into the machine and was analyzing the threads with a probe. He was changing the camera.
Und die erste Bohrung war ja mit dem Kernlaufbohrer 4,1 mm. Da ist sogar noch alles in Ordnung. Da könnte es halt auch passieren, dass die Gutseite nicht mehr reingeht. Und
the first three have been the ones, or the first one was with a bigger tool size. And here he also said, here we already struggle with the quality. Okay, so to summarize and to give you the data again with the bending with the spike data in the analysis software, we are looking at axial force, torsion, and bending moment, and we have here the different colors. Sorry, it's also still in German. The blue one is without mistake, the orange one is without centering, the green one is with an offset to centering, and the red one is with a tilting error. None of these effects can be seen in axial force and torsion, but we can see it really nicely in the bending moment graph. The bending moment is totally out of tolerance, especially in the offset and with the tilting error. So only here again you can see that the threading holes can be seen, that the different quality can be seen in the threading operation, also with spike. But as I said before, the thread might also break if the bending moment is too high because the pre-drill is not good. So the bending moment signal, one can see which quality effects mistaken pre-drills have on the threading process. I have prepared the slide a little bit more in detail. Here you can see again now the differences. This is without mistake, with centering, with offset to the centering, and with a tilting error. Especially with an offset to the centering, we have the biggest bending moments. And why not putting here a limit and to say every time when you reach that limit, we know it's a broken or it's out of tolerance. So our summary is, in order to monitor the process stability and the quality processes of pre-drilling, you should do the monitoring of the pre-drilling and the threading, which should be monitored. By looking at the drilling process, as you remember, we have presented you the new tool control center software, and we are having now the advanced set where you can start and stop the measurement automatically. You will have envelope curves and you will have a long time trigger. With the envelope curves, you see here, this is the good process, and here we have the bad process, which reached out of the curve. But still, we are not at the end of tool lifetime. In threading, it looks the same. These are still in tolerance, but if we get out of the static curves, we can identify bad processes. With the advanced set, you can have a very quick setup in your production. And with a new tool control center software, you can use the alert functions for envelope curves and long time trigger. And with this setup, it is the optimal equipment to do long time tests and even long time verification of your products or of your line production. And this is now available. We are reaching the end of session 5, and I hope I was able to reach your expectations. And now I would like to remember you and show you the speeches we are going to have during DMAP from 1st and 3rd of July. As you know, there will be several companies from the industry which represent also the value chain. You can receive more information from www.digitalmachining.de. And now I would like to introduce the 3 exclusive speeches from our side. The first one is cutting edge based in-process monitoring even for small tools or low power processes. We will have the first one for it's the best time for Asia to join at 8 o'clock German time AM. And then we will continue with at 9 o'clock AM with German, and we will have an English and a French session at the same time at 4 p.m. German time, mainly the Western American or Western countries will join here. The second topic will be the route to smart data in process analysis and monitoring, data interpretation within the tool control center. Here we want to discuss the Spike Polar function again. We want to introduce the Spike KPIs more in detail with you. We talk about Spike AI, and we even show you experiences which we have done with the Spike map, where we can connect the access data with the force data from Spike. The third meeting will summarize the whole product package of pro-micron. Here we talk about digital assistance in all situations, and it doesn't matter if you have a small production or small lot size production or a mid one or a mass production site. pro-micron has the right solution for these requirements. We will introduce live the Spike Assist solution. We will talk about differentiate to the expert line set and to the easy inline set. You're welcome to go to that website. You can find these events, and by just clicking on the buttons, you will find the registration, which is for free. This time, probably DMAP in following sessions as an online event, it will cost in the future. How did you like the webinar? As usual, it would be very interesting to get here a little feedback. You have the first a very simple chance. Open the chat function and give me a thumb up. Or you can even mention this time it was not such good, what we can improve, especially on technical features for the DMAP. Or if you want to discuss the Spike technology, data interpretation, or specific user cases for analysis or even for monitoring, if you know about cases from your customers, or as a tool manufacturer, if you even want to talk about new business models which we can achieve with Spike, feel free to get in contact with us directly, and our sales guys or product management will talk to you in person. So thank you very much for joining that webinar. It was a pleasure, and session 5 is now over as well. And I will have a look in the chat function if you have placed any questions. Otherwise, you can still mention it directly. Thank you very much.